Okay, in this video we are going to use Avogadro's principle to figure out how many moles of gas are needed to fill 81.0 liters. And it says that we are first at 15 degrees Celsius and we need 1.2 moles of gas to fill 43.0 liters. So the first thing that we need to notice about this problem is that we're at 15 degrees Celsius, which is not STP. So we cannot use 22.4 liters equals 1 mole for this problem. We cannot use that because we're not at STP. So instead of using 22.4 liters, we are going to have to solve for our variable of how many moles of gas are needed to fill 81 liters by using the proportion V1 over N1, or initial volume over the initial number of moles, equals the V2 over N2, or the final volume over the final number of moles. So we're not actually going to use this temperature value at all. It's almost extra information. It's really just there to remind us that we are not at standard temperature and pressure. So 22.4 will not work. So instead we are going to use V1 over N1 equals V2 over N2. So we have 1.2 moles of gas filling 43.0 liters. So our initial number of moles, N1, and then our initial volume, V1, and it says how many moles of gas we're looking for N2 are needed to fill 81 liters, so V2. So we have consistent volume units, liters and liters, and then our N2 value is going to come out in moles. So we have our consistent units, so all we need to do is substitute in some values. So I'm going to actually do that over here. V1, let's see, 43 liters over N1, 1.2 moles, equals V2, which is 81 liters, over N2, which we don't have, so we're going to substitute in X. And I'm going to go ahead and circle that so we remember that that is what we're looking for. That is our value of X. Okay, so now we just need to cross multiply. So 43 times X is going to equal 1.2 times 81. 43X equals 81 times 1.2, and I'm leaving out my units here to make it easier to look at our algebra. So let's go ahead and 81 times 1.2, that gives us 97.2 equals 43 times X. Now we just need to isolate X. We have 43 times X, so we're going to divide by 43 on both sides. And when we do that, we end up with X equals 97.2 divided by 43, which is 2.260465. We'll write out all those decimal places, but of course we are going to have to round to appropriate significant figures. In our problem, we have 3 significant figures, 3 significant figures, and 3 significant figures. We're going to round 2.26, and then the 0 of course makes that 6 remain a 6. So our N2 value, moving back up over here, our N2 value is going to be equal to 2.26 moles. And that is our final answer.